Hello, my name is Charlie Hull. I work for the Carnegie Observatories, and I'm going to try to answer a question concerning why astronomers always want bigger optics and bigger telescopes. The main reason for larger optics, larger diameter telescopes, is it allows you to collect more light, and it allows for a larger, higher resolution imaging of the objects you look at. So I have as an example here a couple of lenses. This is a camera lens. And if you look at the image that it makes of the sun, which is down here on this piece of paper, it makes a fairly small image. It's not very bright. At least not very bright compared to how big the image is that's produced by this fairly large lens, which concentrates a lot of light. All the light that falls on it gets concentrated in that one little spot on the piece of paper. And that allows you to get a much faster exposure and see much fainter objects. The other reason that you want a large lens, or a large mirror, in the case of most modern telescopes, is it allows you to resolve smaller things in the distance. Usually a lens about this size, that is 120 millimeters or so in diameter, would let you resolve, if it were manufactured perfectly, about a 1 arcsecond diameter object. That's 1 arcsecond is an angular measurement of size. Now, the human eye, which is much smaller than this, can only resolve an object that's about 120 arcseconds across. So it's actually 120 times less resolution than this lens can make. 1 arcsecond is very good. The best you're likely to do on the Earth through the Earth's atmosphere, which tends to distort images, is about a half an arcsecond. So that's, in theory, the best. You could get images good enough with something, with a lens that's about this big. Bigger than that, and you're really starting to deal with the distortions due to the Earth's atmosphere. This is a reason why it's nice to put telescopes in space, because they don't have that distortion. But even in space, there is another limiting factor, which is how well the optics are made. And very few optics are perfect. Actually, none are perfect. If you measure something accurately enough, you usually just find more errors at a finer and finer level. So right now, on the Earth, the best we can do in optical astronomy is on the order of maybe a quarter or a tenth of an arcsecond, maybe a little bit less under very special conditions and with very, very special equipment. I hope that helps answer some questions about why astronomers want bigger telescopes. This is Charlie Hull from the Carnegie Observatories. Thank you.